Hey, welcome back to the shop, and today we're going to start working on the guard for my slip roll. The last video or two, well, last two videos I did mounted the motor, built the motor mount, gearbox. I took off the old hunk of junk stuff that some previous owner had cobbed to it. It was a belt drive, like a timing belt, and it was about 3 foot long, and the motor went to the floor, and it's set up on like a sawhorse. Real crappy design, didn't work, belt slipped, so eliminated all that. And you see in the last video where built this, modified this gear to fit this metric shaft on the gearbox. Got that. It's a 1-inch shaft here. So basically, I was going to connect them both together, but it ran too fast. I don't know if I wanted to run that fast or not. I needed to gear it down some more. This is a 46-to-1 gear reduction, and I have a 45 tooth to 18 tooth, I believe, and that about cut that speed in half. I don't know the RPM of what it's running, but it's running slow enough now to where I feel comfortable feeding pieces in it and it not taking it in so fast. But I think it'll work for what we're doing. Right now, basically, I'm going to do the guard. So I got a bunch of measurements. When you're making guards, you'll need your shaft sizes, your center to center of your shafts. You'll need that. You'll need your diameter of your sprockets or pulleys or whatever you're using. And then you'll have to come up with a number diameter for the guard to clear everything. So I'm going about an inch, a little over an inch larger than the diameter on it. I'm also putting in, these bolt holes are over on this side also, but this is how I'm going to bolt it on. The guard of 4 bolts here in this diameter, so I had to find the center of the radius on that. So basically I stuck 2 bolts in the holes, measured from outside to outside, subtracted 1 thickness of the bolt to get my center radius, and I put that into CAD, and then I did an array of 4 bolts on the array. We'll go over to AutoCAD here in a second, but this one will get bolted on, come up to here, then I have a hole in here on this piece of the guard, and then it'll get connected by a strap, just like a regular guard, and we'll get it, got some tabs to weld on it and some other things to connect the two together. All right, we'll go over here to AutoCAD and I'll show you the cartoon that I got drawn up. Laid everything out with my shaft sizes and my sprocket dimensions, and then I lay in a guard, and then I connect them basically, and then off of here, that's my shaft size, but right here is my diameter of the hole centers, the 4 holes, and then I just put that into an array. Alright guys, hey, sorry about that. I just got going on it and realized I didn't have the camera rolling. So here's what I do. I'll lay the strip down, clamp it down. Need a flat spot, you know, something hard like a fab table. I got a square block clamped down to the table here behind it. And then I lay that strip down, and then I'll clamp this side piece of the guard to the block as I roll it. That way you don't, because you can get all this out here all kind of screwed up and bowing out and bending in, and holding it down to the table the best you can. I'm actually pushing down harder than I am rolling it, and then I'm using then I clamp it to that block, and it's held down, squared. It's just you got to hold this side down so it doesn't want to roll in. And I just put a bunch of little tacks on it. Can't get in there. That one looks like crap. Couldn't quite reach that one. Yeah, didn't even take. That's alright. Then I just slide the whole thing back. Keep this bottom plate square to that block. And do it again. Push down and roll. Slide it all down against, keep everything square against the block. Push and roll. start getting into problems there again. My clamp. Well, everybody ought to have at least one or two of these. You hardly ever use them, but when you need something like that with a lot of reach, you got them. And just go buy the cheap ones or something. I mean, you don't have to buy the high dollar ones. And I also started from the bottom of the guard, so you'll never see this seam. That'll be one continuous piece. That seam that's on this side you'll never see. Getting a little hot. Getting to the point now where I really don't need a clamp. To keep it pulled back square into the corner. Just use a clamp and a few more tacks on it before I start rolling around that edge. Alright. You know, if a feller had a sheet metal roll, it'd make this a little bit easier. I do have a Harbor Freight spot welder, the one that's the high voltage single phase 220. This guard's stainless, 18 gauge. It'll do it fine. I'm just spot welding. Took some leftover stuff and put it on my brake and bent it, and then I'm going to spot weld them to the guard. So let's see if I can't do this without screwing it up. And this works. I mean, if you got 220, get this spot welder. It does work for almost everything it says it'll do. Now it works great on this thin stuff. I do have some 3/16 stainless perforated. You've seen in another video that I did. And it worked great on that. See? I didn't even get that one. Sometimes when that copper is a little dirty, like, you know, I've used it quite a bit. I think sometimes if you file these off or clean them off a little bit, they'll work a lot better. You can see the spot welds. I'm warm. And if you hear that noise in the background, I have my snow plow tractor, one of my old Cub Cadets, out there running. It's been sitting outside for several weeks, so it hasn't ran. Now I'm just going to drill a couple small holes. Then I have these sheet metal screws that I'm going to run in it, and then I'm going to try to keep the screw back here, and then I'm going to trim this clip off. Okay, everything's tight. Alright, there it is. Nothing rubs. Running at a pretty good speed. Had to move my mic, get my mic back on me. But there it is. It's stainless. Don't have to paint it. Don't worry about it. Even if it was steel, I probably wouldn't paint it. I'm not going to paint that. So yeah, I just got it set up here. It'll be off over that way on the table, out of my way. But I just went through my scrap pile and got some stainless 18 gauge that I had in the junk pile. Cut off the little bits and pieces to it. I kind of got it rough set. You take about your thickness close to it here on this roller, and then there's adjustments down here to raise and lower this one, which is actually the drive. So luckily I already had it up, so, and the chain is tight, so all I can do is go down. So I have it pretty close. I can go up a little more, but the more up I go, the tighter the chain gets. So kind of a design flaw on my part. I didn't pay attention to it. But and then on the back one, it has its own adjusters that take it away from the roll. So I don't know what kind of roll we're going to get, or even if it's even going to work. Oh, that's much better. Then you just give these a half a turn to bring that back roller in. Sometimes you need to rotate your parts around because it'll roll funny on one end from the other. Usually leaves about a 1 inch flat on it. So if you want to get rid of this 1 inch flat, you, like this one here that has the flat on it. Half crank. And as that rolls right there, it takes that flat out of the end. So you want to rotate your parts around quite a bit. You know, then you could change stuff up a little bit and do all kinds of artwork and stuff. Yeah, because I'm going to be doing some windmills. So that's kind of how you do. Just get a pattern and then, you know, take a scrap piece and try to figure it out. You know, that's too much, but I want to make some windmill propellers. So just for yard art and stuff like that. So that's how you do that. All right, guys. I'm glad I got that done. It was a pain in the butt using it before, and then I probably haven't used it most of the summer just because I took the motor off and haven't had time to mess with it. So that's done, off the list, and we'll see you in the next video.